Good morning, children. Let's start today's class. Okay. Let's have some fun with strips of papers. I brought some strips of papers for you. Just here is a whole strip of paper. Can everyone see this? Now I will fold it into two parts. Okay. Now just see the whole strip of paper is divided into how many equal parts? Two. So each part is half of the whole. Yes. Now see this side. Out of these two equal parts, how many parts are colored? One. So tell me what fraction of this strip is shaded? 1 by 2. Yes. What fraction of the strip is colored, children? 1 by 2. So this colored part is represented by 1 by 2. Here is one more strip of paper, children. This again I will fold it. And I'll give two folds for this. Okay. Now see. The whole strip of paper is divided into how many equal parts? 4. 1, 2, 3, and 4. So, out of these 4 equal parts, each part is called as 1/4 of the whole strip. Right? Now see, out of the 4 equal parts, how many parts are colored? 2. So tell me, what fraction of the strip is colored here? 2 by 4. So, see here children, the strip of the paper is divided into 4 equal parts. Out of these 4 equal parts, 2 parts are colored. So, this strip of paper is representing what fraction for the colored part? 2 by 4. Right? Here is one more strip of paper. Now I'll fold this again. And now I will give 3 folds for this. Yeah, just I'll open this. Now count children into how many parts it is divided. 1, 2, 3, 4, 5, 6, 7, 8. So the whole strip of paper is divided into 8 equal parts. So each part is 1/8 of the whole strip. Now see, out of these 8 equal parts, how many parts are colored? 1, 2, 3, and 4. So, out of 8 equal parts, 4 parts are colored. Now, tell me children, what fraction of the strip is colored? 4 by 8. So, this is represented by 4 by 8. Now, see children, what do you observe in all the 3 strips? This is half is colored out of 2 equal parts. And this one, 2 parts are colored out of 4 equal parts. And here, 4 parts are colored out of 8 equal parts. Those all are different. But do you see here? Do the colored parts look the same size? Here, from here to here, from here to here, and here to here. All the colored parts look the same size? Yes, but they are represented with different fractions. Same area is colored but represented with 3 different fractions. Same area, different fractions. So here see, 1 by 2, 2 by 4, 4 by 8. In these 3 strips of papers, colored parts are equal, but they are represented by different fractions. What does it mean? They are equal. Understood, children? So, this is what we are going to learn today about equivalent fractions. What are we going to learn today? Equivalent fractions. So, what does it mean? Equivalent fractions means What I told you? Same area, different fractions. Same area, different fractions represent equivalent fractions. Understood? Equivalent fractions. So let's see this with one more example. What is this tree, children? Here, here is one more triangle, right? The first triangle, tell me children, into how many equal parts the first triangle is divided? 3. 1, 2 and 3. When it comes to the second triangle, now tell me into how many parts is the second triangle divided? 1, 2, 3, 4, 5, 6. This is divided into 6 equal parts and this triangle is divided into 4 equal parts. Now see the first triangle. Out of these 3 parts, how many parts are shaded? 1. So what fraction of shaded part is represented in the first triangle? 1 by 3. Coming to the next triangle, children. Here, how many parts are shaded? 2. Out of how many equal parts? 6. Now, what fraction is the shaded part here? 2 by 6. Now, here, the shaded area is same in both the triangles. Yes, the shaded area is same in both the triangles, but they are represented with two different fractions. These are called as equivalent fractions. Same area, different fractions represent the equivalent fractions. Now let's visualize equivalent fractions with a colorful video in our Tata class board edge. Okay. See here, this video first starts with a beautiful conversation with two people. Just see. What are equivalent fractions? How are you? Yeah, it's been a while. How are you? I have the papers with me, so why don't you come over here and then we can discuss it. Okay? All right. See you. Bye. Hey, Nursa. How was the family lunch?
Oh, don't ask. I'm coming from there directly, and all I want now is a bed to sleep. We've eaten so much.
Looks like you've had a feast.
Oh, yes, pizza feast. Between
What she wanted to eat, children? Pizza. She's starving. She didn't had her lunch properly, so she wants a pizza for her lunch.
four of us, we almost tried every pizza on the menu. But you know what? Who's remembering you while eating pizza?
How sweet. Did you want to share a pizza with me?
No, no, I never share my pizzas. I remembered you because the pizza pieces set me thinking.
Ah, tell me what it was.
See, when the waiter got our pizza, he divided it into four pieces.
The whole pizza is divided into how many equal parts, children here? Four equal parts. She don't want to share it with anyone. She only wants for herself. Okay, see what's happened. Ah, tell me what it was.
See, when the waiter got our pizza, he divided it into four pieces. But for my cousin's table, I saw that he had divided pizza into eight pieces.
Same pizza is divided into 8 equal parts.
Because my cousin got two pieces, but I got just one. My father insisted both of us got the same share, one fourth of the pizza.
Hmm. Let me tell you about equivalent fractions.
What are they?
What is he going to explain her here? Equivalent fractions by using a pizza.
Let's learn these in detail. Imagine you are starving and your mother ordered a pizza. She cut it into two pieces.
See, same pizza in three different places. The first pizza is divided into how many equal parts? Two equal parts.
One and two. You ate one of the two parts up.
Out of these two parts, she ate one part. So, what fraction of pizza she ate here, children? 1 by 2.
The cut pizza.
I ate one half of the pizza.
Correct. Now the next day, the same thing happened. That you were hungry and mom got you a pizza. But this time, she cut it into four parts. You ate the same amount of pizza, which is this piece and this piece.
That's 2 upon 4.
Yes. And if we had cut the pizza into eight pieces, then the same amount of pizza would have been how much?
1, 2, 3, and 4 pieces, which is 4 upon 8.
Now, see, children, mummy ordered pizza one day and she ate half of that pizza as the pizza is divided into two equal parts. So, she ate this area. Okay, this portion she ate. This next day, mummy ordered the same pizza, but now mummy divided it into four equal parts. Out of these four equal parts, she ate two parts. So here, one part she ate, here she ate two parts. What is the amount she ate? This much amount, right? The same pizza mummy ordered the next day, but this time she divided it into eight equal parts. But she ate four equal parts out of these eight equal parts. So, first day, one part, second day, two parts, third day, four parts she ate. So, third day she ate more amount of pizza. No. So all the 3 days she ate equal amount of pizza. The thing is they divided into different equal parts. So same amount of pizza she ate all the 3 days, but they were represented with three different fractions. So what do you understand here? The amount of pizza she ate on all the 3 days is equal. 1 by 2 is equals to 2 by 4, which is also equals to 4 by 8. So what do you understand here? 1 by 2, 2 by 4 and 4 by 8 are equivalent fractions.
Did you notice that the shaded part of all the pizza is the same, while the number of pieces that it is cut up into is different?
Oh, yes. So 1 by 2 is same as 2 by 4, which is the same as 4 by 8.
Understood, children? Now,
We say that
we'll see with one more slide, children. See here. Look at the colored portions and write the equivalent fractions. So, few figures are given and they were divided into different equal parts and few parts are colored out of those equal parts. You need to write the fraction for the colored part and we have to check whether they are equivalent or not. See the first one, children. The first rectangle is divided into how many equal parts? 1, 2, 3, 4. Out of these four equal parts, how many parts are colored? 2. So, what fraction does the colored area represents? 2 by 4. Right? Now, see the second rectangle. You stand up. Now tell me, this rectangle is divided into how many equal parts? 8. Out of these 8 equal parts, how many parts are colored? 4. So what fraction does it represents?
4 by 8.
4 by 8. Good. Sit down. So here this is 2 by 4 and this one is 4 by 8. Both are different in fractions. Are they different, children? No, they are equal. How are they equal? The shaded part is equal. Means the amount of colored part is equal. So they are called as equivalent fractions. We'll go for the next one. Here are two circles. Same, they were divided into different equal parts, shaded in different parts. Just see the first one. Into how many parts is the first circle divided? 4 equal parts. Out of these 4 equal parts, how many parts are shaded? 3. So what fraction does the shaded part represent? 3 by 4. Coming to the next circle, children. See how many parts? 1, 2, 3, 4, 5, 6, 7, 8. This circle is divided into how many equal parts? 8. Out of these 8 equal parts, how many parts are shaded? 1, 2, 3, 4, 5, 6. 6 by 8. 3 by 4, which is equals to 6 by 8. Same area is shaded but represented with different fractions. Coming to the third one, children. Now tell me, stand up. Into how many equal parts it is divided? 3 equal parts. So, out of these 3 equal parts, how many parts are shaded? 2 parts are shaded. So, what fraction does the shaded part represent? 2 by 3. Very good. Now, this one, let's count into how many equal parts this rectangle is divided. 1. Tell me, 1.
5, 6, 7, 8, 9, 10, 11, 12.
The whole rectangle is divided into 12 equal parts. Out of these 12 equal parts, how many parts are colored? 8 parts are colored. So, how you will represent the shaded part? 8 by 12. Both are equivalent fractions. How?
Parts are same.
The colored area is same, but they are represented with different fractions. Same area, different fractions represents what? Equivalent fractions. Come forth, sit down. Now tell me, into how many equal parts is the first figure divided? 4. Out of these 4 equal parts, how many parts are shaded? So, what fraction of the shaded part is represents? 1 by 4. Now tell me, the next figure is divided into how many equal parts? 1, 2, 3, 4, 5, 6, 7, 8. Out of these 8 equal parts, how many parts are colored? 2. So, the fraction that represents for the shaded part is 2 by 8. Are they equal? Yes. Same area is shaded but with a different numbers. Understood, children? So these are what? Equivalent fractions. Now see, children, if the figure is given, you can find out whether they are equivalent fractions or not by seeing the shaded area. But what if the figures are not given? How will you find out the equivalent fractions when figures are not given? So that we will learn here. See, children, suppose we will take one fraction 1 by 2. I wanted you to write the next equivalent fraction of the given fraction. Do you have any figures here? You don't know. You don't know how many parts into how many parts it is divided and how many parts are shaded to write the next equivalent fraction. So, how you have to find out an equivalent fraction? So, to get an equivalent fraction for the given fraction, all you need to do is you need to multiply numerator and denominator with the same number. Okay, let's take one number, for example 3. Okay, numerator is 1. We need to multiply numerator with 3. Denominator also with 3, means same number. You need to multiply numerator and denominator with the same number to get an equivalent fraction. Now see, 1 times 3 is 3. 2 times 3 is 6. Okay, here we multiply numerator and denominator with 3. We got 3 by 6. So actually, what is the given fraction? 1 by 2. The fraction we got by multiplying numerator and denominator with 3 is 3 by 6. So both are equal. So this is how you will get equivalent fractions when the figures are not given. So one more example, children. Let's take 4 by 5. What we have to do? We need to multiply numerator and denominator with the same number. This time let's take 4. Multiply the numerator with 4 and even denominator also with 4. So 4 times 4 is 16. 5 times 4 is 20. So, which two fractions are equivalent here? 4 by 5 and 16 by 20 are equivalent fractions. This is how you have to find out equivalent fractions. So, to find out equivalent fractions, we have two methods, children. One is by multiplying and one is by dividing. See, let's see by multiplication in today's class. Okay. See, here we have properties of equivalent fractions well designed in our Tata class edge board. If you see here, children, if the numerator and denominator, this is what I told you now, numerator and denominator of a fraction are multiplied. Okay, by which number? Same number except 0. Okay, we should not multiply with 0. If you multiply any number with 0, you will get 0, no value. So, you need to multiply with any number other than 0. The value of the fraction remains the same and an equivalent fraction is obtained. Okay, children. Here he beautifully explained here with the examples. He took the fraction 4 by 6 and he multiplied this 4 by 6 with the numbers 2, 3 and 4. Okay, 4 by 6 multiplied with 2 by 2. Here 4 by 6 multiplied with 3 by 3. 4 by 6 is multiplied by 4 by 4. See the first one. 4 times 2 is 8. 6 times 2 is 12. 4 times 3 is 12. 6 times 3 is 18. 4 times 4 is 16. 6 times 4 is 24. So, what is the first fraction? 4 by 6. When you multiplied with 2 numerator and denominator, you got 8 by 12. When you multiply numerator and denominator with 3, you got 12 by 18. Finally, when you multiply numerator and denominator with 4, you got 16 by 24. So, these all fractions are equivalent. 8 by 12, 12 by 18, 16 by 24 are equivalent to this 4 by 6. Understood, children? Now here we have an activity beautifully designed here. Okay, come Prajwal. Stand here. Just hold the pen. Now tell me. The first rectangle is divided into how many equal parts? 6. Out of these 6 equal parts, how many parts are colored?
5.
5. So, what fraction is the colored part representing? Right here, 5 by 6. Yes. 5 by 6. Very good. Now, this one. Into how many parts this rectangle is divided?
12.
12. Out of these 12 parts, how many parts are colored?
10.
10. So, what fraction is representing the shaded part?
10 by 12.
Yes, right. 10 by 12. Now, I have a question for you. Both the fractions are equal is telling. I'll write here clearly. 5 by 6 is equals to 10 by 12. He said both are equal. When we will get an equivalent fraction? When we multiply numerator and denominator with the same number. Now tell me, with which number is multiplied 5? You got 10. Yes, 5 times 2 is 10. So, denominator also to be multiplied with the same number. What is that number? 2. So, 6 times 2 is 12. Now, 5 by 6 and 10 by 12 are equivalent? Yes, good. Go sit down. We'll go for the next one more example, children. Can you see these circles? Yes. Now, tell me, how many equal parts are there in this? The circle is divided into how many equal parts? 8 equal parts. Out of these 8 equal parts, how many parts are colored? 2 equal parts. So the fraction for the shaded part is 2 by 8. Now come see. See the second circle. Into how many parts it is divided? 4. Out of 4 equal parts, how many parts are shaded? So the fraction for the shaded part is 1 by 4. Now see children, the same area is colored. Yes or no? 1 second. In both the circles, the same area is colored. Yes or no? So both the fractions are equal. Yes. Same area, different numbers represent equivalent fractions. Now here is one worksheet for you. See children. Fractions equivalence using multiplication. Now here are 4 different questions. See the first one. The given fraction is 1 by 2. Here numerator and denominator are multiplied by the same number. So 1 times 5 is 5. 2 times 5 is 10. Both are equal, children. In what way they are equal? Numerator and denominator are multiplied by the same number. See, next question. See, next one, children, he gave the fractions, both the fractions, but he didn't give which number to be multiplied. That we need to find out. 7 times how much? You will get 28. 4. 7 times 4 is 28. So, we multiply numerator with 4, even denominator also to be multiplied with 4. So, 4 times 4 is 16. 7 by 4, 28 by 16 are equal. Okay. Now, see the third one. Here, one fraction is 3 by 8. Numerator is multiplied by 6. Denominator he didn't give. With which number to be multiplied? The denominator also. Why? Because he kept here equal symbol. Means both the fractions are equal. When can be two fractions are equal? When they are multiplied numerator and denominator with the same number. So here also you need to multiply with 6. 3 times 6 is 18. 8 times 6 is 48. This he already gave. The last one. he has to, now you have to fill three boxes. Here the first fraction is 7 by 9. He gave the numerator, here denominator is not given. 7 times how much is 35? 5. So 7 5s are 35. So denominator also you need to multiply by 5. 9 5s are 45. Now you understood, no? Today what do we learn, children? What are equivalent fractions and how to find out equivalent fractions when there are no figures. Okay, finally we'll have a quiz. We'll play a game. Shall we play a game?
Yes, miss.
Yes. Here, there are different levels to play the equality game, to fraction equality game. We'll start with level 1 for today. Okay. Here, these both are weighing pans. See, when the weighing pans will look similar, when the weight on both the pans are equal or same. So that you should select from this. Suppose I'll fill the first pan with this, children. Out of two parts, how many parts are colored? One. So what fraction is this representing? 1 by 2. So equal to that you should select from all these figures. Stand up, Ethan. So in all these options, which will be equal to this? It may be a fraction or it may be a figure also. Which one shall we select? 1 by 2. Okay. Check. There is an option to check whether your answer is right or not. Yes, you are right. Here is a smiley face and the marks you are getting also it is shown. Is it nice, children? Shall we go for the next one? Sit. Now, I'll take now this one. The first pan is filled with 3 by 4. Stand up. Now, tell me with what I have should fill the next one pan? 3 by 4 fraction. How is this 3 by 4? Out of 4 equal parts, 3 parts are shaded. And shall we check whether our answer is right or wrong? Yes. This is how you can check. Is it funny? Yes, ma'am. This is, sit down. This is about today's class. And one more thing is, here are fraction fans for you children. Can you see the fan? Here, see the first fan. These are all the equivalent fractions for the given fraction. What is the given fraction here? 2 by 10. You will get when you multiply numerator and denominator with the same number. When you see here the first petal here. So, it is multiplied with 2 by 2. You got 4 by 20. When you multiplied with 5 by 5, you got 10 by 50. Like that. So these are all the equivalent fractions for the given fraction 2 by 10. In the same way, here for the fraction 3 by 4, these are all the 7 equivalent fractions for the given fraction. Understood, children? So your homework is you need to prepare a fraction fan, equivalent fraction fan for the given fractions. So homework fractions are you need to prepare for these. Okay, children? 2 by 3 and 4 by 5. Everyone prepare fraction fans. How you will prepare? The given fraction you need to write here and around you have to write the first 7 equivalent fractions for the given fractions 2 by 3 and 4 by 5. Understood, children? How is the class for today? Nice. So now you understood now what are equivalent fractions and how to find out equivalent fractions when there are no figures by using multiplication. Okay, children, that's all for today. Let's continue in the next class. Thank you.